Hey everyone, Andy Raffel from eTeknix.com, and we all know with the RTX 3080 series recently, there's been a lot of talk about bad capacitors. Well, what if it was only just bad software? Let's do this. I wish these files would transfer faster. Come on! Whoa, is that the Furmark 510 NVMe drive with its blistering fast speeds of 3450 megabytes a second read, 3200 megabytes a second write, and capacities of up to 2 terabyte? I can have these files transferred in no time. And if I'm looking for the ultimate performance, I could even get the 4th generation Furmark 520. I better check the link in the description to find out more details. So let's have a little bit of a recap to start with things. Basically, it stems down to Igor's lab posting some findings that were, I guess, very speculative, all about the 3080 and potentially the 3090, and all to do with the capacitors that are on the back of the GPU core. So if we take the Asus one, for instance, you can see these MLCC capacitors behind the GPU core, so multi-layered ceramic capacitors. On the Zotac Gaming, and I will strip this down so you guys can see it, it has got a polymer type capacitor. So they both have their benefits, they both have their pros, they both have their cons. A lot of it comes down to the voltage range and also the capacity, the electrostatic interference or noise, or however you want to word it. They both have their benefits. The problem is there's been a lot of talk, I guess, from within the community where people are maybe misunderstanding things or they're misinformed. And I don't want to point the blame at anyone because I don't think anyone is to blame. I just think there's maybe a lot of people have taken something, very much like the whole AIO situation and how apparently you're not allowed to mount your AIO in any other way apart from having the hoses at the bottom, which is absolute ludicrous sort of mentality. So what does that actually mean? I mean, a lot of people went out there and said, well, I watched a video or I read an article, which was all very speculative. So I don't want to blame Igor. I don't want to blame Jay. They haven't done anything wrong. They've basically said, this is our findings. And based on that, this is what we think is the problem. And this is what could be the situation and the solution. But the problem is people sort of maybe didn't even watch the whole video or maybe didn't even read the whole article. They took 2 minutes of it and went, do you know what? I'm now an electrical engineer. I know everything, I'm going to go out there and tell the world. And this is where kind of misinformation and miscommunication starts, and it turns into a little bit of Chinese whispers. So I'm hoping today that I'm actually going to be able to kind of clear things up a little bit, and I'm going to make it clear from the offset, I'm not an electrical engineer. I've spoken to electrical engineers and electricians over the last couple of days. I've spoken to AIBs and some of the product managers for these particular graphics cards, and I've got some information from them. And some of it is, well, very, very crystal clear. Some of it, maybe not so much. So one thing I do want to get out of the way is on these graphics cards, and from what I can tell, again, I'm not an electrical engineer, but there are 2 different types of capacitors. You have polymer capacitors and multi-layer ceramic capacitors, or MLCCs, the tiny little ones that you see predominantly on the Asus cards. The Founders Edition cards, there's 1 bank of it. MSI, there's 1 to 2 banks of it. The rest of them are SP caps, which are made from polymer. The problem is a lot of people have been calling them POS caps. Now, POS caps are actually made by Panasonic. It's kind of like you cannot specifically buy a POS cap without it being made by Panasonic. It's a little bit like optical ports. You and I may know them as optical ports. Technically, it's called a Toslink because it's actually made by Toshiba. You can't use that terminology unless it's sort of specifically made by that brand and released from that brand. So I want to get that out of the way from the get-go that POS caps is the wrong terminology because none of these cards, from what I can tell, have POS caps on there. From my own research, it does seem like the last card that had POS caps on there was the 2080 Ti Strix from Asus. Before that, you're going all the way back to the 590. And this is something that Buildzoid actually commented on as well. And I'm sure if you want to go watch his video, it's about an hour long. So, you know, sit down, grab a cup of tea or a coffee and really sort of try and digest it as much as you physically can. But POS caps do not exist, from what I can tell, on the whole 3080 series or the 3090 series. Yes, there may be some polymer capacitors that actually look very, very similar markings. But again, from what I can tell, they are not POS caps at all. Which kind of brings me on to what EVGA have done. EVGA have actually released a statement to say that they have looked into this problem and they are changing all of the cards that have POS caps to MLCCs. Well, the problem is, EVGA, from what I can tell, your cards didn't have POS caps on there to start with. So are you just trying to I don't know, blow smoke up the public's backside, because if you haven't got something, how can you change something to something else? Kind of feels like maybe a PR person has put this claim out there and not someone who's actually technically minded. Again, I might be wrong on this. I might be misunderstanding it completely. Maybe they're just using the word POSCAP as a general terminology for a polymer capacitor. If they are, as a company, especially one like EVGA who are actually making these cards, you shouldn't be doing that. Now, the other element of this is NVIDIA. Where do they kind of come in? Because they have kept very, very quiet over this whole kind of debacle. Now, you'd think with NVIDIA, they would have issued a statement pretty much straight away. And they have actually issued one now. And it all comes down to a driver update, which is what I've been saying pretty much over the whole weekend, that this doesn't seem like a hardware-based issue. Doesn't seem like the capacitors are at fault. Especially when you hear claims about people on Linux not having any issues whatsoever. And I've got to admit, since my driver sort of update and testing, I've had no problems whatsoever. And I will show all this to you as well as we kind of go on in games and also in sort of further benchmarks. So while a lot of this may seem like it's just me doing a kind of, you know, sitting behind a desk talking about stuff, I think really we need to get to the bottom of this and firstly, take off this cooler so that I can show you exactly what an SP cap looks like in comparison to an MLCC. And then we can actually do some testing and show you, I guess, real world situation, what's happening, or more importantly, what's not happening. So these are two cards. We've got the Asus TUF 3080 and also the Zotac Trinity. And the reason I want to focus on the Zotac Trinity is because it's been the one that's kind of got the most flack out of all of the 3080s out there. Apparently they're using cheap capacitors. Apparently they've cheaped out. Apparently they're worthless. They're useless. All this kind of stuff. So we've probably all seen the comparison kind of differences between MLCCs and POS caps or SP caps. So these are MLCCs. You can see that they're in banks of 10 and there are 6 of these particular banks. That's pretty much all I'm going to say about this card because apparently that is, you know, not affected at all. This is the one that we're talking about. So we want to take off the backplate and sort of see really what it's all about. Now, the problem is to take off the backplate, you actually have to, by the looks of it, take off the front of the cooler. Luckily, I've got my handy dandy eTeknix toolkit, which have arrived the other day. And they have pretty much everything that I need to take this apart. So you can actually buy this on store.eteknix.com. So let's get into it and see exactly what it's all about. So this is what it looks like when you've actually taken off the main part of the cooler. And there are a few little connectors that we need to take off, predominantly for sort of RGB and things like that. So we can just look at taking them off. And this is kind of what we're left with, really. So what we want to do now is actually disconnect the main part of the back plate, which, as I say, there is plenty of RGB on here. So on the top and also on the back. So once we've disconnected that, we can put the main part of the cooler to one side and then look at taking off the rest of the screws for the back plate, which looks to be just 2 here. So we've got the first one and the second one. It's always handy having a magnetic screwdriver as well. And then we are left with the main part of the kind of frame that's held onto the PCB. And we have a screw here. And a screw here, just holding the I/O together. Which we can take off. And now, that frame comes off. And we can, with a little bit of pressure, because there are sticky pads on here, remove this and get a better view as to what we're looking at when it comes to the capacitors. And as you can see, this is a reference-based design. There's a few little added extras from Zotac, but as you can see, we've got our capacitors just here. And even though they do look very, very similar to POS caps, they're just not. They are SP caps. They have very similar, I guess, markings to POS caps, but again, they are SP caps. With POS caps, you would see a very distinct kind of design, and I invite you to go and sort of have a look on Google at the differences between the two. But I wanted to get this out there so you guys could see exactly what we're dealing with here. before we actually test it. So now that I've done that, let's put it back together. Right, so everything's back together. So hopefully you guys have understood kind of what this card has. I'm just going to plug it back in, and I am using 2 DisplayPort cables because I'm using an 8K 60Hz monitor, and that's the way that on this particular one it works. It has got 2 8-pin connectors on this card. It's exactly the same card as what I just stripped down. So you guys are going to be able to see exactly how things do in terms of benchmarking purposes, as well as just your general gaming and stuff like that. So I'm going to move probably around to the other end of the desk so you guys can see exactly what's happening on the screen as it happens, and we can maybe dispel all this kind of capacitor nonsense completely out the window. Okay, so I've booted things up, and I mean, there's no point me testing at stock. There was some, I guess, indications of people running at stock and having issues, but I just feel that's completely unnecessary. If it's going to crap out, it's going to do it while we're overclocked. So standard boost at 1710. I know based on my live stream yesterday that I can go higher than that, but I want to do sort of a modest overclock, I guess. So I went to 130 yesterday, but was having stability issues, had to have loads of fans on the test bench, and I don't really want to do that today because this isn't kind of, you know, I'm trying to think from a real world consumer. So instead, I'm going to increase things up by 80 megahertz. That takes the boost clock up to 1790. And then in theory, if the capacitors were an issue, then we wouldn't be getting anything above 2000 megahertz on the boost. And straight away, I'm running this at 4K. This is an 8K screen, so hence why it looks a little bit smaller. But you can see straight away that we're running at 2070 megahertz, 2055, and so forth. So I'm going to walk away and let you guys enjoy a sped up time lapse of this doing its thing for just a little bit. So it's been running for a couple of minutes now. You're going to have to take my word on it, but I've been running this constantly, and I did so yesterday on the live stream before and after as well, and it was running comfortably, even actually higher than this, at around 2100 megahertz on the boost. This is flipping between 2055 and 2070. I ran this for absolutely hours, but for the sake of this video and not making it stupidly long, I just wanted to kind of give you guys a little bit of a taster as to what it's like. And you got to remember, this is Furmark, okay? So we are looking at maybe something slightly different to the way that a game would react. But if anything, you'd think with Furmark putting so much stress onto the GPU, especially if it was a capacitor issue, you'd be getting kind of artifacts, you'd be getting problems, it would be crashing, it would be doing all sorts. And you can see, temperature-wise, I haven't got any extra fans on here. It's on an open-air test bench. We're running at 72 degrees max. And if anything, if I was to put this in a test bench, because I know people will comment on that, if anything, I'd actually expect slightly better results because we'd have more airflow from sort of case fans and things like that. Right now, it's pretty warm in the office. It's about 24 degrees. There's no aircon in this office whatsoever, apart from a portable unit that isn't turned on and hasn't been turned on today. And it's just the GPU running on its own steam. Even the CPU cooler is running at standard mode within the BIOS. Nothing extravagant going on there at all. And still, we're not getting any crashes. GPU usage is at 98 to 99%. Now, a lot of people are going to say, well, what about games and things like that? So one of the games that people were complaining about, and I showed this yesterday as well, was Shadow of the Tomb Raider. So I'm going to load that up and we can see exactly kind of what's going on there. So if we look in the options, DirectX 12, we're at full screen, we're running at 4K with RTX and DLSS on, and we're running at high settings. This should, in theory, give us close to sort of 100 frames per second. Yeah, it's a pretty demanding game overall, especially on high settings at 4K. So yes, we could run it a little bit higher on sort of ultra settings, but you know, why would we? We're literally trying to get it to crash, and that's kind of what we're hoping for. Okay, so again, here's all of our settings, and I'm simply going to run the benchmark. And again, you guys are going to have to take my word on it, but I've ran this benchmark at least 20 times, one after the other, after the other, after the other. So there'd be a lot of people saying, well, what if it's a heat issue? You're going to see straight away from the temperature up in the top left corner, which I haven't seen it go anywhere above 72 to 73 degrees, but it's definitely not a temperature issue. So again, we are seeing it go above 2000 megahertz. We're at 2010 there. It's sort of obviously peaking, troughing, whatever you want to call it. It's going up and down as you'd expect a boost clock to do so, but it's definitely going over 2000 megahertz or 2 gigahertz. Temperature of the GPU again running at 72 degrees and 98% of its utilization. And we are getting some decent frame rates. There's no artifacting, there's no crashing, and based on previous experience, Shadow of the Tomb Raider is very volatile. If something isn't working right with your GPU, Shadow of the Tomb Raider will let you know about it. It will crash. Generally on the last scene, if anything. But we are still seeing it go above 2000 megahertz, which is the thing that I guess predominantly people were talking about. And I've tested this in a variety of games. I've tested Metro Exodus, obviously in this, Wolfenstein Youngblood. One of the main ones that I can't test at the moment, just because I haven't got it downloaded onto the system, is Warzone. But I'm pretty confident that with the driver update that NVIDIA released yesterday, as well as what I've actually done within Windows, which I will talk to you guys about in a second, I honestly believe that this isn't a capacitor issue. It is software related, and pretty much now it's fixed. Again, we're peaking up even higher now. So this is a bit I really wanted to show you. 2010, 2025, 2040 megahertz. If this was a capacitor issue, as a lot of people said about in the start, then surely this would be crashing to desktop right about now. But it's simply not. And admittedly, I was getting the smallest of problems when I overclocked before, but now I'm not getting anything. No problems whatsoever. And that's why I honestly don't believe it's a capacitor issue. It has to be software related, because all I've done is change software in terms of updated drivers and things like that, and I'm getting what I'm getting now. And there you can see it's finished the benchmark run. Now I could run this 20 times over. For the sake of the video, I'm not going to. Average frame rate 109 FPS. So let's get out of this and load up another game that I know has had problems in the past, and now will be absolutely fine. Okay, so Battlefield 5, the first thing that I want to show you is the settings, because a lot of people are saying, well, it's not always at 4K. So again, I'm trying to go through every kind of scenario. So at the moment, I'm running at 1080p, 60 Hertz, because this is an 8K 60 monitor. Settings-wise, we've got DX12 enabled, we've got ray tracing enabled, DLSS is on, everything is set to high. So, you know, pretty demanding stuff, even at 1080p for any graphics card. And you can see again, 2070. It's clear as day on the top of that screen. So let's just, you know, see what it can do. And I've played this game for absolutely hours trying again to get it to bug out. And it simply won't. Because there is no issue with it. So you can see it is fluctuating, 2055, 2077. The GPU temperature is around where we expected. And if I now change it to 4K, just again to take any doubt out at all, 3840 by 2160 at 60 Hertz. We haven't got VSync on or anything like that. But again, you can see it's a little bit lower on the boost clock, but it's still well above 2055, 2025, 2010. Well above the numbers that I guess we weren't potentially able to get according to a lot of people out there. So yeah, it's still doing it. So the only other thing that I changed on top of the driver, which obviously came out yesterday, so I would invite everyone to go and download that driver. If you have a 3080 and you've been having problems, there is talk of even people, and I've seen some reports of people getting improved performance with lower temperatures now that they are on the newer driver. And that is one thing that I did. So I'm now on 456.55. The other thing that I personally changed, and maybe this is something that I need to do more testing of, but if you go into your display settings, scroll down to graphics settings, and you will see hardware accelerated GPU scheduling. And this is a big thing that caused a lot of problems on Navi on the 5000 series. Reduced latency and improved performance, you'll need to restart your PC to have changes take effect. See if that is enabled. I'm probably guessing that it is, because mine was, and I disabled it. Now that I've disabled it, it's absolutely fine. And this is something that actually came on Windows, I believe, in the May 2020 update. And I think it may be causing some issues with regards to how the GPU is working through Windows and in conjunction with the driver. So what does all this mean? Well, I'm just one guy. I am a guy who happens to have multiple 3080s. I had the MSI one until recently as well, but you know, with the Asus, with the Zotac, and I've done extensive testing off camera on as much as I physically can, especially with the new driver update and just disabling this one setting from within Windows that we all know caused mass amounts of problems with Navi when that launched with the 5000 series. So I actually invite you guys to go and test this yourself. Go and download the driver, do some tests. If you're still getting it, disable this, or try it with the old driver and disable this. I mean, there's only so much testing I can do, and that only really gives a small pool of information. But based on the information that I have got, I can honestly say I have no problem with any form of capacitors here. And I am going to call out some brands on it. Some brands have actually been very, very good. I love Inno3D and kind of what they said about it. It's like, no, it's fine, go buy it. Which I think is a brilliant way of doing it, because there's no scaremonger in there. EVGA, I'm very worried about the fact that they called them POS caps instead of SP caps, and the fact that, I don't know, maybe they are trying to change something that doesn't potentially even need changing. Obviously, like I mentioned, I'm just one guy. Igor had his own kind of speculation and everything on it, and I'm sure he's going to do some more testing as well. Jay did kind of his own thing as well, and obviously a lot of that was speculation. The problem was the community maybe misunderstood some of the information that was being put out there, and hopefully this has cleared up a lot of that for you guys. So really, I'm going to leave it with that, but I do invite you to actually, you know, comment below with what kind of results have you had on the old driver, disabling this one single setting within Windows, and even then just updating the driver in combination with this setting in Windows as well. Because as you can see, in Furmark, in Shadow of the Tomb Raider, in Battlefield 5, I've got no problems going above 2 gigahertz. Sometimes, in some cases, even above and beyond that, up to 2130 I was getting yesterday. So yeah, check out my live stream that I did yesterday, and you'll see for yourself exactly what was going on there. And the other thing that really I want to sort of make clear is this card, this one, for instance, MSRP, is 1710 megahertz on the boost clock. If anyone's expecting it to get 2300 megahertz, which I have seen in some of the comments, I honestly think you're maybe barking up the wrong tree. And yeah, I mean, that's just not feasible in any shape or form. I am actually going to put a water block on this card, and I'm going to see sort of how far, even above and beyond what I've been able to do, how far I can push it, because, you know, there are some records to be broken, and maybe, you know, I can get a little bit higher up on the 3D Mark scores, and it's going to be interesting to see, once we completely take out thermal sort of regulation and thermal throttling, what can these cards really do? So that's definitely something I'm going to look to do in the near future. Hopefully you enjoyed this video, and hopefully it gave you a bit of an idea as to why you shouldn't believe everything that you see and just take everything off of one opinion or one piece of speculation, and why you should do your own research. And that's why I'm inviting everyone who has a 3080 to do what I've said and come back to me and let me know what's happening. Maybe this is a one-off for me. Maybe I'm one of the lucky ones. And I know people are actually going to say that maybe I've got a better binned card because it's a review sample. That's not always the case. I can honestly say that hand on heart. I've had review samples that have been retail, pre-production, all sorts. And yes, while the results do vary, yeah, I don't think that's the situation here. And I honestly don't believe there is a problem with your capacitors. So can everyone please stop saying that MLCCs are better? They both have their pros and cons, and MLCCs technically are cheaper as well. So when people say these cheap, crappy POS caps and SP caps, no, that's just completely wrong wording. So there you go, guys. Hopefully you enjoyed this video. If you did, you know exactly what to do, and I will see you in the next one. See you later, guys.